Find the distance from the gazebo to the dock. So we are trying to find this side. Okay, so I mean I have a little bit of a hint that law of sines is probably going to help because that's what's new in this section. So I know if I'm trying to find this side length with law of sines, I need to pair it up with the sine of its opposite angle. So if this whole thing is 74 and this much of it is 28, then this much of it must be 74 minus 28. Okay, and then for law of sines, we need to pair that up with another side length that we know. So probably the 100. And he has to be put over the sine of his opposite angle. So if I can figure out this angle down here at the dock, then I can solve and get the answer that they're wanting. Okay, so I'm gonna guess, since I need more angle information, you know, my first thing I would probably lean towards is trying to think about 3 angles of a triangle adding up to 180, but that doesn't seem like I've got that information. So then it must be something with these bearings, especially since they're giving me that information. So I think similar to question 47, this one, we probably need to use these parallel lines. North line is always going to be parallel to a north line. So all those angle relationships that you learned in geometry, you know, the one that I always look for, I just picked this one just for consistency, but alternate interior. So the interior means I need to be looking inside the 2 parallel lines, and then to alternate, like if I look at this transversal, this angle is on the bottom left of the transversal, so he's going to alternate with the top right of the transversal, and they're both in the interior because they're inside the 2 parallel lines. And the nice thing about them being parallel is that if this is 74, that should be 74 as well. So that allows me to say, all right, well, half of these, or these 3 make up half of a circle. So I could find that angle at the gazebo from 180 minus 74 minus 41. And now I have 2 of 3 angles of a triangle. So 180 minus this 46 minus this 65 gives me, this angle is 69. And that was really the last piece of the puzzle that I needed. X, the distance they're asking us to find, will be 100 sine of 46 degrees over the sine of 69 degrees. So it should just be a matter of plugging that in, making sure that the answer seems realistic. If it doesn't, you might check some parentheses. You might check to make sure that you're actually in degree mode. Since this is degrees and this is degrees, your calculator needs to be degree mode. But it looks like it's about 77 meters. That's what I would expect it to be. Now again, I know this came up a couple times first semester, and doesn't come up a lot, but this highlighted part is probably the hardest part of the question, only because you don't get to practice it as much. So it's not something that I would try to do on every single question, but if you know you need more angles and you can't figure out something else, you need to think about the parallel lines, make one of these be a transversal, and then if you don't want to use alternate interior angles, that's fine, but you need to use one of those angle relationships so that you could get something else. I took this 74 and used that to know that this would be 74 too. And then just like on your practice quiz, anytime that you have to do that, I don't know if that is on the practice quiz or not, but if the angles are supposed to be the same size, and obviously they should look the same as well. You know, it's kind of hard to eyeball it, but if you think some angle on a quiz is 74, and then you think some other angle is also 74, but they don't look the same size, that might be a red flag that you're not using that correctly.